Hi everyone, my name is Nathalie Ramirez and today I am going to tell you about in silico characterization and three-dimensional modeling of the transmembrane serine protease 2 from musculus. Well, the unprecedented outbreak of SARS-CoV-2 required a series of structural studies related to transmembrane serine protease type 2 due to its importance in viral infection. However, there are still limitations regarding the knowledge of the structure of the mouse TMPRSS2 that hinder studies in this model organism, such as the lack of this crystallized structure. For this reason, this study aimed to characterize in silico and computationally predict the three-dimensional structure of TMPRSS2 from musculus. Well, about the methodology, we obtained the amino acid sequence using UniProt database. Also, the ProtParam tool was used to predict the physicochemical characteristics of the mouse TMPRSS2 protein. Identification and annotation of conserved domains was done with ProCyte. The secondary structure of the protein was predicted with the PhD secondary structure prediction method. And also, several 3D models of TMPRSS2 were built using different strategies such as AlphaFold, homology, treating, and affinity. Also, the quality of the predict models was evaluated with the PDB-Sun generates and matfold servers, and the stability of the TMPRSS2 homology model was evaluated using integrated GROMACS tool, and molecular docking was carried out using Autodock program. Well, as a result, we found that TMPRSS2 contained 490 amino acids with a molecular weight of 53.5 kilodaltons and pI of 8.10. And also the secondary structure of the protein is composed by 30.99% beta sheets and 7.29% alpha helix. Also, the structure of this protein showed high similarity to other serine proteases, mainly those of Homo sapiens, which was used as a template. Modeling was obtained with 100% coverage and 83.78% confidentially, allowing the recognition of the active site. And here we can see the three domains of proteins is the low-density lipoprotein, the scavenger receptor cysteine-rich, and finally the serine protease domains that contain a conserved catalytic triad of amino acids such as serine, histidine, and aspartate. And our results of validation and statistical analysis of the models obtained by homology, treating, affinition, and AlphaFold indicate that AlphaFold and homology are potential models since they presented the highest percentages of the summation from the number of residues located in the favored and additional allowed regions of the Ramachandran plot. Also, this result is based on estimation of the error of the results belonging to the serine protease. And our results of the simulation of molecular dynamics indicate that the model of the proteins by homology presented greater stability according to the RMSD value values in 10 nanoseconds. And finally, the results of the molecular docking of the TMPRSH2 with 10 inhibitors based on the binding energy and the inhibition constant indicate that the compound zinc 64, 60, 60, 47 show the highest affinity values with the TMPRSH protein from musculus. Furthermore, these protein amino acid residues involved in the interaction are part of the catalytic triad. Well, in conclusion, this protein TMPRSH2 from musculus was characterized and modeled from a three-dimensional model of SRCR and serine protease domains generated by homology modeling after comparing several models obtained by homology, 3D, and ab initio methods, and AlphaFold algorithm. In addition, this study showed a higher affinity with the inhibitor zinc 64, 60, 60, 47.